Here we have exercise 5159. It's a really difficult exercise because it's an optimization exercise again. So we start with this function minus x squared plus 4x. This is the parabola here, and the function has a tangent line in this point a f of a, which means that it's an arbitrary point on the graph, tilfeldig punkt på grafen her. And we first want to find the tangent line, the equation of the tangent line of this function. And that we can do in cos. We just define the function like this, and then we just use the command tangent line, and I also just define it like g of x tangent, and the number here is a, the x coordinate is a, and the function is f. And then we get this answer, which is actually the same as in the exercise here. If you factorize out x in these two terms, you will get the same answer. I don't want to show this, but it is the same. And then we have this triangle here, which is the one corner is the origin, and then the other corner is this intersection point between the tangent line and the x-axis, and the last corner is the intersection between the y-axis and the tangent line. So what I have to do here is to find this point here, the intersection between the tangent line. This is the tangent line, g of x. This is the 0 point to the tangent line, so I have to put it equals to 0. And to find the y-coordinate of the intersection here, I have to calculate g of 0. When x is 0, I need to find the function value of the tangent line, which then gives me the y-coordinate. So and then this answer here, the x-coordinate of the 0 point will be the baseline. If the x-coordinate is 4.5, then the baseline is 4.5. And remember that the area of a triangle is 1/2 times the baseline times the height. So I will find the baseline here, and the height will be this y-coordinate here. This will be the height here, like that. So let's use cos here now to find the 0 point. Here is the 0 point. Not cool here. There's this g of x equals to 0. Then I have to press x equals to. So this is the 0 point. The x coordinate to the 0 point. So this is the baseline. I can define it as the baseline. B colon equals to. Just press this. I just have to take away x equals to, and like this. This is the baseline, and the height is g of 0, which is 8 squared. So I define this as h. And then I can find the area. The area is then 1/2 times the baseline times the height, and we get this expression. So this is the expression, and this is a function. The area is a function of a, so I can call this h of a. And now I define it, colon equals to. Just press this and take away a equals to, like this. See if that was correct. No, like this. So here we have the function like this. So this is the area. No, everything goes wrong here. Yeah, this is the area, and it says in the exercise a is larger than 2. So I can't see anything yet. I have to find the graph here. It is this red one here. I just take away the parabola here, like this. So here is the function. Here's the area. So this only works if a is larger than 2. So we don't have to look at the other things here. So this graph, again, this function is area function. The x thing here, x-axis is a. So that's the x-coordinate of the tangent line point. And the y-coordinate here is the area. So you see we want to minimize the area of the triangle, it says. So I have to find the minimum point of this graph. And I can then just do this graphically if I want. Since I have a graph here, just press here. So we see that a has to be 2.67. Okay. If a is 2.67, then we have the least area of this triangle, and then the area is 18.96. So the point here, if you want to understand what we did now, we had this this parable here, and by taking different points here, when a is larger than 2, we get different triangles. But the best triangle, if you want to minimize the area, is the tangent line. I just write tangent here when a, the point x coordinate is 2.67, and now we have f here, right there. No, that didn't work for some stupid reason. Let's try and do it over up here. 2.67. Yes, there we go. Let's try again. Let's call it k of x. This is the parabola here. We had answered the question a long time ago, but just to make impression of what we're doing, it still doesn't work, so we have to open a new window. This is the fun thing about cos. Like this. Let's try again. F of x is equals to minus x squared plus 4x. This was the parabola. Right. No, still not working. Then we have to open the program again. I would really like to show this. You can just turn it off if you want, but let's get cos up and running here. There we go. And if I take this just to show what we actually found here. There we have the parabola, right? And if I take a tangent line, for example, the x coordinate should be larger than 2. It says let's take 3 and f. I get the tangent line here, and I get a quite large triangle here. If I take tangent line to the same function when x is 3.5, I will also get a quite large triangle here. But if I want to minimize the area of this triangle, I found in the exercise that a has to be 2.67. The x coordinate of the tangent point has to be 2.67. Then I get this line here. This is this one, the last one here, and this will be the triangle with the least area. Okay, I hope that makes sense. But a real difficult exercise, 5.159.